If you take a look on the back of your cheat sheet, I'm going to be starting where it says significant figures, and we're going to tackle the rest of the cheat sheet today. So as we start to tiptoe into numbers for the first time, we're going to look at numbers from a distance first. So what I mean is, before we start calculating anything, we want to identify what numbers mean to us. A value can theoretically go on forever as far as like a decimal number goes, but only some digits are considered significant. To be significant, it's a number that we are certain of, or the number of digits in a value that we're certain of. And the first thing you're going to be tasked with today is learning how to count significant figures. Now, when I say count significant figures, what that means is I'm going to give you an actual number, and you're going to tell me how many of the digits in that number are considered significant. How many of those digits are we totally sure of in regards to our measurement? And there's 4 different rules that are going to govern how we do this. So taking a look at your cheat sheet, you can see the 4 rules right there. And we're going to examine them one by one so that you can get this skill. Rule number 1. All non-zero numbers are significant. Non-zeros. How many non-zero numbers exist? Not a lot. How many non-zero numbers are there? There's not a lot. There's I can count them on my hands. How many? There's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all of the numbers that are not zeros. Now, you could combine those numbers to make a bunch of other numbers, but those are them, 1 through 9. So rule number 1 says that anytime you run into one of those numbers, it is significant. How many significant figures are there in the value 43? There's 2. All right, I would say this is 2 significant figures because they're both non-zeros. So looking at some different examples of values, look at this one. How many significant figures are there in the number 222? Now see, there's your first argument. One of you said 1. Well, there's just the number 2 a bunch of times, and one of you said 3. The answer is 3 significant figures. All we're doing is going digit for digit. You're just identifying each individual number as either significant or not. That's not a 0. It's significant. That's not a 0. It's significant. And so on. So 3 significant figures in this example. What this means is it's just the zeros that can cause us problems on whether or not a number is significant. And the next 3 rules on your cheat sheet deal with that idea. I lost my eraser. Rule number 2 states that sandwiched zeros are significant. What does it mean if something is sandwiched? In the middle of other stuff. Let me show you a sandwiched 0. $7,099. Let's do rule number 1 first. Rule number 1 is non-zeros. 1, 2, 3 non-zeros. So right away we know those 3 guys are significant. And then we've got this 0. And he is significant because he's sandwiched. A sandwiched 0 is a 0 that falls between non-zero numbers. In other words, it's a 0 that doesn't start the number and a 0 that doesn't end the number. It's in the middle of the number somewhere. This has 4 significant figures. $30,033. Starting with rule number 1, non-zeros. I see 3 non-zeros right away. Those 3 guys are definitely significant. Are these guys significant? Yes, they both are, because both of them are sandwiched zeros. Yeah, they're next to each other, but they're both in between non-zeros. They both are not starting or ending the number. 5 significant figures. Any questions so far? Rule number 3 and 4, look at the other two things zeros can do. Zeros can end a number or start a number, and these are the ones that will cause you problems, so focus. Rule number 3 states, zeros that end a number are significant if you can visibly see a decimal somewhere. If the person that gave you the value shows you a decimal. Do you see a decimal in that expression I wrote? No, you don't see one. Is there a decimal? Is there a decimal though? All numbers have decimals. Where's the decimal in that number even though I'm not showing it? It's at the very end. But that doesn't matter. Listen to the rule one more time. Zeros that end a number are significant if there's a decimal shown somewhere in the number. Right in this expression, there are no decimals. Do you agree? Therefore, how many sig figs are there? Say it. Just one. He's significant. They are not, because there's no decimal anywhere. This would be one sig fig. But watch what I can do. Now it's the number 100.0. How many sig figs do you think there are now? 4. Now all of them are. Here's how it works, guys. Those zeros at the end of the number come as a package. They are either all significant or they're all not. If there's a decimal anywhere in the number, then they all are. If there's not a decimal anywhere in the number, then they all aren't. So watch. How many sig figs are there now? 1. Just the 1, because there's no decimal. How many sig figs are there now? 4. As soon as a decimal shows up anywhere, all of the zeros at the end of the number become significant. Now there's 4 sig figs. How many sig figs are there now? Only 1, because the decimal's gone. How many sig figs are there now? 4. As soon as a decimal shows up anywhere in the number, all of the ending zeros become significant. Come up with an answer in your head. That says 3.40100. In your brain, see if you can tell me how many sig figs you think that number has. How many? All of them are significant. And I'm just going to go rule for rule. Watch how this works. Non-zeros are significant. Sandwiched zeros are significant. Zeros that end a number are sometimes significant. Do you see a decimal anywhere? Hey, look, there he is. They are significant then. There's one more rule, because there's only one more thing that zeros can do, and that's start a number. And here's the rule for these zeros that start a number. Zeros that start a number are never significant, ever. Decimal or not. And here's where you're going to get really confused, because you're going to look at that decimal and be like, well, wait a second. Something's up here with that decimal. No, all of these zeros start the number. None of them are ever significant. One sig fig in this example. Couple practice, and we'll move on with life. See if you can tell me how many sig figs there are in all 3 of those. Write them and solve them in your brain. How many sig figs in the expression 340? Only 2. Non-zero, non-zero. Ending zeros are significant if you can find a decimal somewhere. Do you see a decimal in that expression? Nope, there's no decimal. So this one has 2 sig figs. How many sig figs in the second expression? Just 1. Starting zeros are never significant. Now, some of y'all said, hey, look, there's a decimal there, so maybe the zeros to the right are. No, no, no. All 3 of those zeros start the number. And none of the zeros that start a number are ever significant. 1 sig fig. And then the granddaddy problem here. How many in this expression? 4. Non-zero, non-zero, sandwich zero, ending zero, sometimes significant. Do you see a decimal anywhere? Yep. Starting zeros never are. Fun, right? The second one only has 1 because all 3 of these zeros come as a package and they all start the number. Zeros that start a number don't care about that decimal.
So if the flop is like the first number, if the flop is like a 0 like that, the second 0, that one, then it would be 3 significant.
1, 2, if there was still a 5 there also, then yeah. That 0 still wouldn't be significant, but that 0 would become significant in your question. Other questions?